Hi guys, let us learn the quicksort algorithm through an example. So here a list of numbers is given. We are going to apply quicksort on the given data. In the list, you start with the first element as pivot element, and the next to the pivot you mark it as a left pointer, that is L, and mark the right end as a pointer with the name R. Here I have chosen first element as pivot, but actually in quicksort we have the choice of choosing any element as pivot, but it is better or easier to start with the first element as pivot. So that is why I start with the first element as pivot. And another thing is, the selection of pivot will result in number of steps will differ according to the choice of the pivot element, but we suggest always we start with the first element as pivot. So you start with first element as pivot, and the next to the pivot is marked as L, and the right end is marked as R. Our next task is start looking for element greater than pivot from the left end. So what is a pivot value? 19. So we should look for the value greater than 19 from the left end and start looking for element lesser than pivot from right end. That means we should look for the element which is lesser than 19 from the right end. So currently left pointer L points to 33, which is greater than 19, and currently the right pointer R points to 9, which is lesser than 19. So we swap these two values and continue to move the left and right pointers. That means 9 will come in place of 33 and 33 will come in place of 9. The logic is move the elements which are greater than 19 from left side to right side, and move the elements which are lesser than 19 from the right side to left side. After the swap, 9 is in second place and 33 in last place. Then we have moved the left pointer one step and also the right pointer for one step. Now again start looking for element greater than pivot from the left end and start looking for element lesser than pivot from right end. So the pivot value is same 19, but now currently the left pointer L points to 15, which is lesser than 19, but actually we are looking for the value greater than 19 from the left side. Like that, currently R points to 32, which is greater than 19, but from the right side we are looking for the value lesser than pivot value 19. So there is no need to swap and continue to move the left and right pointers one step. In the previous step no swapping was done, but we have moved the left and right pointer one step. Now you do the process again, that is start looking for element greater than pivot from left end and start looking for element lesser than pivot from the right end. Currently left pointer L points to 3, which is lesser than 19. Currently R points to 1, which is also lesser than 19. But you should observe that in the left end we should observe for the element which is greater than pivot, but in the right end we are looking for the element lesser than pivot. So there is no need to swap, but continue to move only the left pointer to reach the element greater than pivot. Why I am moving only the left pointer? Because the right pointer points to the element which is lesser than pivot, but in the left side I am expecting the element which is greater than 19, but currently the pointer points to the element which is lesser than 19. So no swapping will be done, but move the left pointer one step. And also the point is swapping will be done only when these two conditions are satisfied, that is L points to element greater than pivot and pointer R points to the element lesser than pivot. We have moved only the left pointer L one step further. Still the right pointer R points to the same position, that is the element 1. Currently L points to 21 greater than 19. Currently R points to 1 less than 19. So these two conditions are satisfied. So hence swap these two values and continue the process. After swapping, we have moved the left and right pointer one step. Now again we are looking for the element greater than pivot from left end and element lesser than pivot from right end. Currently the left pointer L points to 7, which is lesser than 19, and right pointer R points to 13, which is also lesser than 19. So as we have discussed earlier, so we are looking for the element greater than 19 from the left end, and the right end we are looking for element lesser than 19. So there is no need to swap here and continue to move only the left pointer to reach the element greater than the pivot value. So we are moving only the left pointer one step further. So when you move the left pointer one step further, now left and right points to the same position, that is left pointer L points to 13, which is lesser than 19. Right pointer R points to 13 lesser than 19. But the thing is, the left pointer we are looking for the element greater than 19. But our right pointer R points to 13, which is lesser than 19. So again there is no need to swap but continue to move only the left pointer to reach the element greater than pivot. So when you move the left pointer one step further, what happened in the diagram, you see the left pointer crosses the right pointer. So if that is so, we can conclude that the position pointed by R is the right place for pivot, and so exchange the pivot with the element in the R. That means the position pointed by R is the right place for 19. So 19 will be placed in place of 13. 13 will be placed in place of 19. So 13 will come to the first place and 19 will be placed in this place. Now we can observe that pivot value 19 is in correct position and all the elements in the left of pivot are less than the pivot value 19, and all the values in the right of pivot are greater than the pivot value 19. Now the list is divided into two halves. Now we have to apply quick sort process on the left side and right side separately. The next step is to apply quick sort on left side of the pivot value 19, and the right side of 19 will remain as it is. Now we are not going to make any process on the right side. So the left side of 19 will be considered as a individual list or separate list. We have to apply quick sort on this side, left side of the pivot value. So we have to start the process by considering the first element as pivot. Okay, that is what we have done. 13 will be considered as a pivot. The next to the pivot will be considered as a left pointer, and the last, that is right end of the list, will be considered as a right pointer R. Now as we have discussed already, we have to look for the value greater than the pivot from the left side, and from the right side we have to look for the value lesser than the pivot value. So what is the pivot value now? 13. So L points to 9 less than 13, or right pointer points to 7 less than 13. So no need to swap but continue to move only the left pointer to reach the element greater than pivot, because the left side I am looking for the value greater than pivot, but the current value is less than pivot. But in case of right pointer, it points to the value which is less than 13. So I am moving only the left pointer. So when you move the left pointer, it points to the value 15. So now L points to 15, which is greater than 13, and the right pointer points to 7, which is less than 13. So the conditions are met. That is, L points to value greater than pivot and R points to value lesser than pivot. So hence we can swap these values and continue the process. So after swapping, we are moving the pointer one step, that is both L and R. Now the L points to 3, which is lesser than 13, and R points to 1 less than 13. So as we have discussed already, L we are looking for the value greater than pivot, but the current value is less than pivot. But right side it is pointing to the value which is less than pivot value 13. So hence no need to swap and continue to move only the left pointer to reach the element greater than pivot. So we are going to move the left pointer one step further. After moving the left pointer one step, now we can see that left pointer L points to 1, which is lesser than pivot value 13, and right pointer R also points to 1, which is lesser than 13. So no need to swap and continue to move only the left pointer to reach the element which is greater than pivot. So we have to move only the left pointer one step. So when you move the left pointer one step, what happened now? The L crosses R. That means the left pointer value is greater than R pointer. If that is so, then the position pointed by R is the right place for pivot, and so exchange the pivot with the element in right pointer R. So what is the value available in right pointer now? 1. So what is the pivot value? 13. So 13 and 1 will be exchanged. That means 1 will come to the first place and 13 will come to the place where the right pointer pointing now. So we are exchanging the values. So after exchange of values, the values lesser than 13 are in the left side of 13 and the values greater than 13 are in the right side of 13. So in the right side of 13 there is only one element 15. So we are concentrating on the left side of 13. So now we have to take the left side of 13 or left half of 13 as a separate list and apply quick sort process. So now as usual you take the first element as a pivot and the next to the pivot will be considered as a left pointer and the last element in the list will be considered as a right pointer. So now you start looking for element greater than pivot from left end and start looking for element lesser than pivot from right end. So now what is the pivot value now? 1. So currently L points to 9 which is greater than 1. R points to 3 greater than 1. So hence no need to swap and continue to move only the right pointer to reach the element lesser than pivot, because from the right side we are looking for the value lesser than pivot. So we are going to move the right pointer one step. So when you move the right pointer one step, now the left pointer L points to 9 greater than 1 and R points to 7 again greater than 1. So no need to swap and continue to move only the right pointer to reach the element lesser than pivot. So again if you move the right pointer one step, so both L and R points to the 9 which is greater than 1. So again no need to swap, continue to move only the right pointer to reach the element lesser than pivot. So if you move one step further, right pointer, left pointer crosses the right pointer, that is L crosses R. That means the position pointed by right pointer is the correct place for the pivot element. That means now the element 1 is in the correct place now. So there is no need to do any exchange operation and also there is no left off for the element 1. So we have to focus only on the right half of the element 1. Let us focus on the right half of the element 1. The pivot element is 9. The left pointer next to the pivot points to 7 and the right pointer points to the last element of the current list 3. So currently L points to 7 less than 9, R points to 3 less than 9. So we know that the left pointer searching for the element greater than the pivot element. So hence no need to swap and continue to move only the left pointer to reach the element greater than pivot. So when you move the left pointer one step, now L points to 3 less than 9, R points to 3 less than 9. So no need to swap and continue to move only left pointer to reach the element greater than pivot. So move the left pointer one step further. What happened? The L crosses R. It means that the position pointed by R is the right place for the pivot. So exchange pivot with the element in R. That means the 9 and 3 are exchanged. That means 3 will go to the second place and 9 will go to the fourth place. So after the exchange, so you can find that 9 is in correct position, and also we observe that all the elements left of 19 are in sorted manner. So let us proceed with the right half of 19. Let us focus on the right half of the element 19. Pivot element is 21. The left pointer is next to the pivot, points to 32, and right pointer points to 33. So we are looking for the element greater than pivot from left end and element lesser than pivot from right end. So L points to 32 greater than 21, R points to 33 greater than 21. So there is no need to swap and continue to move only the right pointer to reach the element which is lesser than the pivot value. So when you move the right pointer one step, so now the L points to 32 greater than 21 and R points to 32 greater than 21. So as we are looking for the value lesser than 21 from the right side, so what we are going to do, there is no need to swap and continue to move only the right pointer to reach the element lesser than pivot. So when you move the right pointer one step further, now L crosses R. That means the position pointed by R is the right place for 21. So 21 is in correct place now. So let us proceed with the right half of 21. Let us see the right half of the 21. So the pivot element is 32 and only the last element is remaining. So both L and R points to 33. So L points to 33 greater than 32 and R points to 33 greater than 32. But from the right side we are looking for the element which is lesser than pivot. So there is no need to swap and continue to move only the right pointer to reach the element lesser than pivot. So when you move the right pointer one step further, so it points to 32 and what happened, L crosses R. So in that is so the position pointed by R is the right place for the pivot. So 32 is in right place now. So and also we observe that all the elements are in sorted manner. So we have reached the final solution. So the final list in sorted order.